Assalamualaikum and hello everyone. Welcome to the video for 4.4 reactions in organic compound. In this video, we will learn to explain the covalent bond cleavage, which is in terms of homolytic and heterolytic. We will differentiate homolytic and heterolytic cleavage. We will state the relative stabilities of primary, secondary and tertiary, free radical, carbocation and carbanion, and compare the stabilities of carbocation and carbanion. Okay, so all chemical reaction involve the breaking of bond and the formation of new bond, where the breaking of chemical bond is called fission or cleavage. So for example, we have our carbon-carbon double bond. So when we break the bond here, we will call it as bond cleavage. And mostly we're going to define it as bond cleavage. Cleavage ni, cleave lah. We're going to break the bond itself. So for the bond cleavage, it is divided into two, homolytic and heterolytic. So now let's look for the case of homolytic cleavage. This is where two shared electrons of the covalent bond are split equally between the two atoms. This reaction will occur in a non-polar bond involving atoms of similar electronegativity. Okay, so once the bond is broken, what would form is actually a free radical would form. Okay, so how does it work? In this case, we have our chlorine. Chlorine, so it means that we have the same atom lah kan? So what would happen is that when we break the bond here, since it is the similar atom, it means that it has similar electronegativity. So what will happen is that actually the electrons are split equally. Remember that for one bond we do have two electrons. So what will happen is that one electron will be shared to this chlorine, one electron will be shared to this chlorine. Okay, and then from free radical is actually you have to show the dot here to show that the electrons are being shared. Kan sebab split equally, so each atom got one electron kan. So dot here, dot here. Okay, so for the case of homolytic cleavage, we will use half-headed arrow as one electron is transferred. Okay, that is for homolytic cleavage. Okay, for heterolytic cleavage is where two electrons of the covalent bond are transferred to the more electronegative atom. In this case, it will not be shared equally. In this case, two electrons will choose one of the atom itself. Okay, it will choose the more electronegative atom because electronegative atom means that the ability to attract electron tu is higher lah. So the electron will prefer the more electronegative atom. Okay, for the heterolytic cleavage, it will occur in a polar bond involving atom of different electronegativity. So for the heterolytic cleavage, okay, what is the intermediate that we're going to form is actually carbocation and carbanion. Okay, so reminder, lain je namanya, carbocation, carbanion. So actually, carbocation originally from carbon and cation, so that's why we got carbocation. Carbanion, carbon, and anion will form carbanion. Okay, so for example here, we have our carbon and bromine. So carbon here is group 14, bromine is group 17. In terms of electronegativity, remember that across the period, electronegativity increase. So in this one, bromine is more electronegative. So here what we have is actually two electrons kan? Okay, in this case, the two electrons will be transferred to the bromine. So once the bond is broke, what will happen is that, remember, because the carbon donate dah two electron ni, maknanya dia dah kurang electron, so it become a positive charge. And then because the bromine accept the electron, it will become a negatively charged. Okay, the carbon which have cation, which have positive charge on it, it is called carbocation. Okay, so here we have carbon and lithium. Okay, carbon is group 14, lithium is group 1. Okay, in this case, which one is more electronegative? Our carbon. So when we break the bond here, it will not be shared equally, it will be shared to more electronegative atom. In this case, is our carbon. So again, when we break the bond here, the two electron will be transferred to carbon. So because carbon have accepted the two electron, so it will have a negatively charged. But because the lithium, kiranya dia donate kan, the two electron are being donated to the carbon, so dia jadilah positive. Again, the carbon which have a negatively charged on it is called carbanion. Okay, ni carbocation is where carbon plus cation, carbanion, carbon plus an ion. Okay, in this reaction, we will use full-headed arrow. Full-headed arrow because this is where 2 electrons are transferred. Okay, so that is actually for the homolytic and heterolytic cleavage. Okay, next is actually we're going to talk about the radical, carbocation and carbanion. Okay, so for radical, it's actually a very reactive species with an unpacked electron. Okay, and this radical is formed from our homolytic cleavage. Okay, the radical is very reactive because it seeks for an electron to complete its octet. For example, here we have our chlorine, right? Okay, chlorine originally 7. And then what will happen is that each of the chlorine atoms share 1 electron to form our octet, to achieve octet. But once it undergoes homolytic cleavage, mostly initiated by UV, so what will happen is that chlorine ni kan dia balik tu pada tak capai octet balik. But then in this case, it only needs 1 more electron. Okay, so that's why it will try to search for an electron to achieve octet, to complete its octet. Okay, so that is for radical. Okay, carbocation. Okay, remember, it's actually carbon with a positive charge on it. It is very reactive species with a positive charge on a carbon atom, and this is actually formed from our heterolytic cleavage. Okay, this one, remember that because between the carbon and the chlorine is more electronegative, the electron will be shared to chlorine, so that's why lah, carbon will become a positively charged, which we call it as carbocation. And then for the carbanion, it's actually it is a very reactive species juga with a negative charge on a carbon atom. Again, it will form from heterolytic cleavage. But in this case, what would happen is between, for example, here carbon is more electronegative than lithium. Hence, when the bond break, the carbon, the electron will be transferred to the carbon. Once the carbon accepted the electron, so it will become a negatively charged. So that's why we call it as carbanion. Okay, so that is actually the reaction intermediate. We have our radical, we have our carbocation. Maknanya sini kita punya carbon yang positif, carbanion, carbon negative. Okay, so now let's look for the case of. Okay, so next what we're going to look at is to the state relative stability of primary, secondary and tertiary periodical carbocation and carbanion. So let's look here. The radical carbocation and carbanion can be classified as primary, secondary and tertiary according to the number of alkyl group that are bonded to them. The number of carbon lah attached to the radical carbocation ataupun the carbanion. Okay, so alkyl group ni, again, what is alkyl group? So contohnya, okay, originally we have alkene kan? Contohnya alkene CH4. So we call it as methane. Alkyl group is actually where the alkene tu minus 1 hydrogen. So for example, if we have CH4 methane, if we remove 1 hydrogen from it, we call it as methyl ataupun methyl. Okay, alkene we have ethane, CH3CH3. So we call it as ethane. But then when we remove 1 hydrogen, it is actually an alkyl group. Dia jadi nama dia bukan ethane dah. The name will be ethyl. Okay, so but then for the case here, we're going to denote the alkyl group, in this case as R here. Okay, so let's look for the case, for the explanation. It mentioned that the alkyl group denoted as R has the electron donating effect. So please remember that it has an electron donating effect. Hence, alkyl group is, we call it as electron donating group, EDG. Okay, so sebenarnya for the case of radical and carbocation, it is actually an electron poor species. Because remember, here the carbon haven't achieved octet yet. They need 1 more electron. Okay, for the case of carbocation ni, remember, because the bond is break, kalau tak dia sebenarnya adalah 4 bond kan. It means that it has 8 electron. But then the electron is are being transferred. So carbocation only have 6 electron. So what it means that this radical and carbocation haven't achieved octet. and it is actually electron per species. Okay, so what is the effect of our alkyl group ni? So dekat sini kita tengok alkyl group is electron donating group, and then actually electron donating group ni, because it means that it donate electron kan. So what would happen is that it will increase the electron density to the carbon. Okay. So contohnya kita buat analogi lah. Okay, bayangkanlah elektron per species ni macam kita lah. Kita ni tak cukup, kita ni miskin, tak ada duit. Okay, kita bayangkan our alkyl group yang RR ni, dia kan donating group kan. It means that the alkyl group likes to donate. So yang ni kita compare je lah yang our R ni pada uncle kita. Contohnya kalau kamu ada uncle kaya kan, yang selalu bagi kamu angpau, selalu bagi kamu duit saku. Okay, so what happens is that, okay, methyl radical ni, okay, kita tengok, does it have any R attached to it? Tak ada. Okay, so maknanya kalau kes yang methyl ni yang tak ada, there is no carbon attached to it ni, kesian, tak ada siapa nak bagi duit saku dekat dia, tak ada siapa nak bagi angpau. But then for the case of primary radical, dia ada satu electron donating group. It means that only one yang donate dekat dia. Apa ni? Increase the electron density. So macam kita lah, primary radical ni only one uncle yang bagi kita duit. Okay, but kalau secondary radical, okay, remember that radical ni semua electron per species. Macam kita semua ni kan tak cukup duit. Okay, so yang ini secondary radical, it means that dia ada dua lagi uncle yang bagi duit dekat dia. So what happens is that dia ni lagi stabil lah. So that's why secondary radical is more stable than primary radical. Okay, lastly, tertiary radical. So it means dia ada tiga uncle kaya bagi dia duit. Kira dia sugar daddy bagi dia duit raya lah, duit angpau. Okay, so we know that sama lah juga macam radical ni. Kalau radical ni dia tak ada uncle, maksudnya dia ada alkyl group attached to it. The more the alkyl group attached to it, the more stable lah, because actually the radical or the alkyl group donate the electron, has increased the electron density on the carbon. So here, what is the explanation? Electron donating group increase electron density. Hence, electron donating group ni akan increase the stability. Macam kita lah, lagi banyak duit, lagi lah stabil kan. Best lah dia duit, boleh spend mana-mana. Okay, so here it mentioned that the greater the number of alkyl group on the carbon atom, okay, maknanya we have the higher the stability of our radical or carbocation. So samalah, for the radical and carbocation is the same case. Because remember, it is electron per species. Bayangkan kita miskin ni, tapi ramai pula bagi dia duit. Lagi ramai yang bagi dia duit, lagi bahagia dah dia, lagi stabil lah dia. So that is actually for the case of radical or carbocation. Okay, now it's actually for the carbanion. Okay, carbanion ni terbalik sikit. Carbanion ni is actually an electron rich species, because actually negative ni, it means that it achieve accepted, dia ada 2 electron. So maknanya carbon dekat sini, for the carbanion ni, it actually dah capai octet dah lah. So kita buatlah dot 2 electron here. Okay, ini yang terbalik lah, sebab sekarang ni the electron rich species. So electron rich species ni maksudnya dia kaya. Okay, contohlah kalau kita ni dah kaya kan, kalau orang bagi duit, kalau orang bagi duit kan, will be happy with it. Kalau kamu rasa kamu happy, kalau kamu dah kaya, orang bagi duit, pelik lah kamu ni Bukanlah macam contohnya, you yourself are very able kan, dah kaya dah semua benda, tapi tiba-tiba ada orang datang, nah, ambillah gula ni, ambillah beras ni, nanti mesti kamu akan rasa macam, apa dia ni, kira I am able lah, tak nak semua benda ni, macam tu. So samalah juga dengan your carbanion, because it actually it is electron rich species. Dah kaya dah, tapi kenapa nak bagi lagi? Okay, so kita tengok explanation dia macam mana. Okay, electron density group, electron donating group, again, what will happen is that it will increase the electron density. Tapi dalam kes ni, dia terbalik tau. Electron donating group ni will decrease the stability of the carbanion. Okay, because actually, kamu bayangkanlah, kamu dah kaya, lepas tu tiba-tiba ada orang, dia tak nak donate duit lah, donate beras lah, donate garam lah. Kamu macam, tak apalah. Lagi suka makan McD, macam tu lah. Okay, so here, what happens is that there is actually a repulsion. So actually, Okay. So there is actually a repulsion between the negative charge on the carbon atom with the electron donating effect. So sebab dia tak suka, dah kaya, jangan bagi. So what will happen is that the greater the number of alkyl group on the carbon atom, okay, the lower the stability of carbanion. So sebab tu dalam kes ni dia terbalik, carbanion rich kan. So tertiary ni yang paling the least stable. Sebab banyak sangat bagi duit kat dia kan, ketuk-ketuk rumah bagi garam gula. So macam tak nak lah. So dia tak suka lah sebab ni dah kaya dah. Okay, but then kat sini dia tak ada alkyl group kan. Metal carbanion ni tak ada pun yang donate. So dia yang paling bahagia. So for the case of carbanion ni is the complete opposite of our radical and carbocation. Okay, so that is actually for the stability of our intermediate.